cubed plus m squared equals 810. Okay, now this is called a cubic polynomial equation. Okay, so our equation becomes m cubed, or you can say m exponent 3, okay, plus m squared equals, now 810 is the same as, okay, 81 times 10. All right, so you're going to have m cubed plus m squared equals, now 81 is the same as 9 exponent 2. 10 is the same as 9 plus 1. Okay, so you're going to have m cubed plus m squared equals 9 squared times 9 plus 9 squared times 1, which is 9 squared. Okay, all right, so we are using the 9 squared to multiply the bracket that we have there. So our equation becomes m cubed plus m squared equals 9 squared plus 9 is the same as 9 exponent 1. Okay, and then we have 9 squared. All right, so we are going to apply the first law of indices here. Okay, so a exponent m times a exponent c equals a exponent m plus c. That is, when the bases are the same and the sign in between the bases is multiplication, we add all the exponents. So we are going to have m cubed plus m squared, okay, plus m squared equals 9 squared plus 1. Okay, so we have applied the first law of indices. So here we have 9 squared. So you're going to have m cubed plus m squared equals 9 cubed plus 9 squared. All right, so here we're going to transpose all the components at the right part of the equation. Okay, so we're going to have m cubed plus m squared, okay, minus 9 cubed minus 9 squared equals 0. All right, so let's group all the cubes and then group all the squares. So we're going to have m cubed, okay, minus 9 cubed plus m squared minus 9 squared equals 0. All right, so we have difference of cubes here, and then we have difference of squares here. So we're going to apply the difference of cubes identity and the difference of squares identity to our equation. Now let's apply the difference of cubes identity first. So it says that a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. All right, so our equation becomes, okay, m minus 9 times, okay, times m squared minus, plus 9m, okay, plus 9 squared, that is 81. And then we have plus m squared minus 9 squared equals 0. All right, now the next thing we're going to do is the application. The next thing you're going to do is to apply the difference of cubes, the difference of squares identity, because we have already applied the difference of cubes identity. Okay, so a squared minus b squared should always give us a plus b times a minus b. All right, so our equation becomes m minus 9 times m squared plus 9m plus 81, okay, plus, okay, m plus 9 m minus 9 equals 0. So you can see we've applied the difference of squares identity. Okay, all right, so let's factorize here. So you can see you have m minus 9 and then m minus 9 here. So we bring it out since it's common. So we're going to say, okay, m minus 9 times m squared plus 9m plus 81 okay, plus m plus 9 equals 0. All right, so our equation becomes m minus 9 times m squared plus. So we have 9m, then we have m. So when we add them, we get 10m. Okay, we are adding because they are like terms. So we get 10m. Okay, and then we have 81 and 9. Okay, all right, so when we add, here we have 90 equals 0. All right, so this is what we have. Now here we can apply, okay, this concept. We can say if A times B is 0, then A is either 0 or B is 0. Okay, all right. Therefore, we can say m minus 9 equals 0. Now let's call this equation 1. And then we can say m squared plus 10m plus 90 equals 0. Let's call this equation 2. All right, so you can say from equation 1, m minus 9 equals 0. So m equals 9. Now let's call this m1 since we are expecting other solutions. Okay, so let's call this m1. So m1 is 9. All right, then we say from equation 2, we have m squared plus 10m plus 90 equals 0. All right, so this is a quadratic equation. Okay, so we expect two values here. Now, we expect two values as answers here. Okay, now let's use the determinant to check our equation. Okay, so we say, before we apply the determinant, let's quote a squared plus bx plus c equals 0. So every quadratic equation obeys this form, okay, or has this form. So we're going to compare this to our equation, okay. So when we compare, we see that a equals 1, b equals 10, and c equals 90. All right, now let's state the quadratic formula. So we have m equals minus b plus or minus the square root of b squared minus 4ac all over 2a. All right, so let's apply that concept. So we say m equals minus 10 plus or minus the square root of, now b squared is 10 squared minus 4 times 1 times 90 all over, okay, 2 times 1. All right, so our equation becomes m equals minus 10 plus or minus the square root of 100 minus 4 9 is 36. So you have 4 times 90, 4 times 1 times 90 is 360. Okay, all right, so this is what we have all over 2. All right, so let's subtract 360 from 100. Okay, so you have 100 minus 3. Okay, let's subtract, let's say 360 minus 100. Okay, when we are done, then we negate it. So 0 minus 0 is 0. 6 minus 0 is 6. Okay, 3 minus 1 is 2. So we have 260. Okay, so in this case, we are going to have m equals minus 10 plus or minus the square root of minus 260. Okay, since we are subtracting a very big number from a very small number, so this is what we have. All right, over 2. Okay, so you're going to have m equals minus 10 plus or minus the square root of 260 times minus 1 all over 2. Okay, so our equation becomes m equals minus 10 plus or minus the square root of 260 times the square root of minus 1 all over 2. All right, so we're going to have, okay, m equals minus 10 plus or minus the square root of, this is the same as 26 times 10, okay, all over 2. So this is going to give us, okay, m equals minus 10 plus or minus, okay, and let's quote, okay, a formula from Z here, okay. All right, now if, okay, if the square root of a, when you have the square root of ab, this can be written as the square root of a times the square root of b. So our equation becomes m equals minus 10 plus or minus, and here you have the square root of 26 times the square root of 10, and then here you have the square root of minus 1 all over 2, okay. All right, so our equation becomes m equals minus 10 plus or minus, all right, so this can be written as 13 times 2, okay, and this can be written as 26 can be written as 13 times 2, and then 10 can be written as 5 times 2, okay. All right, so all over 2. All right, so you're going to have m equals minus 10 plus or minus the square root of 13 times the square root of 2 times the square root of 5, okay, times the square root of 2 times the square root of minus 1 all over 2. All right, so our equation becomes m equals minus 10 plus or minus, okay, find the square root of 13 times, here let's bring the square root of 2 here and the other square root of 2 here, and then we have the square root of 5, and then we have the square root of minus 1 all over 2. All right, so this will give us m equals minus 10 plus or minus, okay, the square root of 13 times the square root of 2 times the square root of 2, and that gives us the square root of 4, okay, and then here we have the square root of 5, and then we have the square root of minus 1 all over 2. All right, so we can do this. We can say m equals minus 10 plus or minus, now the square root of 13 can be here, the square root of 5 can be here, the square root of 4 can be here, and the square root of minus 1 can be here, all over 2, okay. All right, so you're going to have m equals minus 10 plus or minus the square root of 13 times, okay, root 5, and the square root of 4 is 2, okay. All right, so you're going to have m equals minus 10 plus or minus the square root of 13 times 5, that gives us 65, okay, times the square root of times 2 times the square root of minus 1 all over 2, okay. All right, so our equation becomes m equals minus 10 plus or minus 2 times the square root of 65 times the square root of minus 1 all over 2. All right, now minus 1, but minus 1 is the same as I squared, okay. So where we see minus 1, we can write I squared. So we say m equals minus 10 plus or minus 2 times 65 times the square root of I squared all over 2, okay. All right, so this will cancel this will cancel this, so you're going to have m equals minus 10 plus or minus 2, okay, times the square root of 65. All right, so let's bring the I here, okay, so the I can be in front of the square root or it can be behind it, okay, all over 2. All right, now our equation becomes m equals minus 10 over 2 plus or minus 2i over 2, and here we have 65. All right, so you can say 2 cancels itself, 1 goes here, 5, 2, 1, 2 also cancels here, 1. So you have m equals minus 5 plus or minus, okay, and then we have I root 65, okay. Now this is the same as m equals minus 5 plus or minus root 65 I. All right, now let's separate the solutions in our equation, okay. So we can say m1 equals minus 5 plus the square root of 65 I, and we can say m2 equals minus 5 minus the square root of 65 I. Okay, so this is our solution. All right, so we've already called the first value for m1. So let's call this m2 and let's call this m3. Okay, so in all, we have 3 solutions, 1 real solution and 2 complex solutions. And these are the solutions we need to get when solving a cubic polynomial equations.